Well, hopefully you've watched the video, The Mole, so you have an idea of what the mole or a mole is, as well as Avogadro's number. So, just to state again, it is a unit of measure, and you are going to learn by filling out this tree map with me how to do mole conversions. So that's what this little lesson can be called, mole conversions. And so there are three categories of mole conversions, and you can see here there's 1, 2, and 3. We will be talking about each of those separately. So I will be focusing in on one section at a time. So if you need to stop and restart, go ahead and do that. All right, so the first conversion will be moles and representative particles. Now, the statement that we can make is that 1 mole is equal to Avogadro's number of representative particles. So Avogadro's number is 6.02 times 10 to the 23rd. So representative particle examples are atoms, molecules, or formula units. Atoms are the representative particles of elements. Molecules are the representative particles of molecular compounds, which are those that are covalent. And formula units are the representative particles for ionic compounds, which obviously are ionic bonds. So when we say representative particles, we mean one of these three things: atoms, molecules, or formula units. So let's look at how this works. You can do two types of conversions, and it could be a conversion from particles to moles or from moles to particles. And so let's look at particles to moles first. So the way that we do these problems is we first read the question and figure out what you're trying to find. So it says how many moles is 2.8 times 10 to the 24 atoms of silicone. So what we're solving for, and I often do this when I am solving my problems, is I will write what it is I am solving for. Now I use the M with a line over it to signify moles. Your book will have it sometimes as MOL, and I do an M with a line over it, so it could be either one of those. So we need to solve how many moles is equal to 2.8 times 10 to the 24 atoms of silicone. So what we are going to do are conversions, and we're going to use something called dimensional analysis. And so the first thing you always do is you write down the number that has been given to you. And in this case, it is 2.80 times 10 to the 24 atoms of silicone. Now, this is a conversion table. So you will draw a horizontal line and you will draw a vertical line. And anytime you have a vertical line when you are doing these conversion tables, that is a multiplication. And anytime that you have the horizontal line, that is a division sign. And I'll explain what I mean by that in a minute. Now, the whole point of doing these conversions is that you cancel one unit and get to a different unit. So we want to convert to moles, and we have atoms. So the first thing you're going to do is whatever the unit is here in the first section should automatically go down here in the bottom of the next section. So I am going to immediately put in here atoms of silicone. Now, this is where our conversion factor comes in. We know that 1 mole is equal to 6.02 times 10 to the 23rd representative particles. So in this case, It is atoms. So atoms of silicone. So we know that 6.02 times 10 to the 23rd atoms of silicone is equal to 1 mole of silicone. And so we are trying to convert to moles, as we figured out in the beginning. So we are done with our conversion table. We have converted to moles. We have canceled atoms, and we can do the math. Now I want to point a couple of things out. First of all, you should consider that these two on top of each other are equal. You should always be able to translate something like this on the bottom where it says this is equal to that to this vertical. So this is equal to that. So 1 mole of any substance is equal to 6.02 times 10 to the 23rd atoms, or representative particles, in depending on what it is that we're talking about. So now to calculate that, what we're going to do is we are going to multiply across the top and divide by the bottom. So in this case, it's 2.80 times 10 to the 24 times 1 divided by 6.02 times 10 to the 23rd. Now I'm going to write down how to put it into the calculator, and this is how you should do it. Don't forget parentheses. Parentheses 2.80 times 10 caret 24 end of parentheses equals divided by parentheses 6.02 times 10 caret 23 end of parentheses equals, and then that gives you your answer. Now try to calculate that a second, and I will as well, and then we will see how our answers compare. Okay, so hopefully you have done your calculation and you have come up with the number 4.65 moles of silicone. Now, I want to point out one thing here. When we were given our problem, we were given 2.80 times 10 to the 24. 2.80 is 3 significant figures. And so when we are answering our question, we need to answer in 3 significant figures. And that's why it is 4.65 moles of Si. So the one we just did was particles to moles. Now let's look at one where it's moles to particles. So here we were given atoms, which are particles, and here we are given moles. So we are going to be going in the other direction. So let's start out by looking at what we have to solve for. So it says how many molecules, and I write the word molecules out so I don't get it confused with moles, of SO3 are in 1.14 moles of SO3. Okay, so we are given this number of moles and we want to know how many molecules that is equal to. So draw the conversion table like so. Always, the very first thing that you're going to do is you are going to put whatever unit is here in the first section, you're going to put that unit in the bottom of the second section. In this case, it's moles. And then we want to convert to molecules, which are representative particles. We know that 1 mole of any substance is equal to 6.02 times 10 to the 23rd particles. In this case, it is molecules. So our 1 mole is equal to 6.02 times 10 to the 23rd molecules of SO3. And I'm done. I have converted to molecules, which is what I wanted to solve for, and I have converted in a proper direction so that I can cancel the moles. Now, just a little side note, for now, anytime you have moles, you will always have a 1 in front of it if it is in one of these conversion factors like this. Okay. Obviously here, a given amount of moles is not 1, but when you go to here and you're doing conversion factors, whether it's the top one or the bottom one, it's going to be 1 mole for now. Okay, so take a minute to calculate that and see if you can get the right answer. Because again, it's really important that you know how to do the calculations. It's kind of a waste if you are not able to work out a problem because you don't know how to calculate it. So when I do this one, I would multiply 1.14 times, and then I would do parentheses. So 1.14 times, this is a point, parentheses, 6.02 times 10 caret 23, end of parentheses, equals. And it would be divided by 1 because it's divided by the bottom, but it's just 1, so you don't really have to do anything. Now, when I calculate that, I get this number, 6.8628 times 10 to the 23rd. Now, our question was given to us with the original number of 1.14, and that is 3 significant figures. So our answer has to be in 3 significant figures. So we're going to have this digit, and this digit, 3 significant figures. So our answer will be 6.86 times 10 to the 23rd molecules of SO3. Okay, so now what we have done is I have showed you how to convert between particles and moles and particles. Okay, so what we have done is we have discussed this section, so that's done. And now I want to talk about this section, which is mass. There are 3 ways to measure, and so what we're looking at are these 3 ways. The first one was representative particles. There's mass, which is in grams, and then there's volume, which is in liters. So it's kind of like if you were to take apples. This would be like saying 12 apples is a dozen. That's by count. If we were talking about mass, we could say something like 12 apples equals, or excuse me, I just did apples when it really should be dozen. You would say 1 dozen apples is equal to 0.2 kilograms. Okay, and in this case, kilograms is the unit of mass. We usually will use grams. And then if you were to count volume or measure in volume, 1 dozen apples would be 0.5 bushels. Okay, and bushels is a unit of measure for volume when you are getting fruit. So you have 3 ways that you can measure. You can measure by count, by mass, and by volume. So we have already talked about count, that is the representative particles. Now let's talk about mass. Okay, so the first thing that you need to know is that the conversion factor. Okay, so our first conversion factor was 1 mole is equal to 6.02 times 10 to the 23rd representative particles. Our second conversion factor is 1 mole is equal to the molar mass. Now, what is the molar mass? All that the molar mass is adding together all of the masses of each of the different parts of the compound. So, for example, if I just forwarded it, but here's the same problem with the C20H42. If I look on my periodic table, this periodic table, we can look for carbon because it's C20H42. Carbon right here has an atomic mass of 12.0. Hydrogen has an atomic mass of 1.0. So we are going to add together 20 carbons. So I have carbon, and there are 20, and each of them is 12.0. So that will equal 240.0. Then we have hydrogen, and there are 42. Each of them is 1.0, so that is 42, for a grand total of 282. And we put that in grams, and that is the molar mass. All it is all the atomic masses of all of the different components added together. So let's look at how we do these problems. So to start, it says find the mass in grams. So we are going to be finding mass in grams of 0.00452 moles of 620 or C20 H42. So we have moles and we want to solve for grams. And this is by mass. Now, whatever's in the top of the first section will automatically go at the bottom of the second section. So C20H42 will be down here. As we've talked about, 1 mole is the conversion factor. And in this case, since we're converting to grams, 1 mole is equal to the molar mass. So C20H42 is the compound, and the molar mass is what we just calculated, which is 282. So what we are saying is we have 0.00452 moles of C20H42, and we want to know how many grams that is equal to. If we know that 1 mole is equal to 282 grams. And so for this problem, all you need to do is multiply together 0.00452 and 282. And when you do that, you should get a number like, let's see, you will get something like this. You will get, and I'm running out of room, so I'm just going to put it down here, so adjust. 1.27464. Now, that is the full answer from my calculator, but we can only answer as in the smallest number of significant digits given. This number only has 3 significant digits, so we can only answer in 3 significant digits. So right here, this would be 1, 2, 3. We're only going out to the hundredths, so our answer will be 1.27 grams of C20H42. Now, I know that you're like, okay, you're showing all this work. You have to show all of these things here because otherwise later on when we have a little bit more to it, it will be a little confusing for you. Now, that was an example of moles to mass. Now let's do an example of mass to moles. And let's do that by doing this conversion right here. Calculate the number of moles in 75 grams of dinitrogen trioxide. Now, you may recall that when you have the prefixes, you will write a formula by just having the number. So dinitrogen, there's 2 nitrogen, trioxide means 3 oxygen. So it's N2O3. We are solving for moles, okay, as asked, calculate the number of moles. And we have been given 75.0 grams of N2O3. So when you take that number, you put it in your conversion table like that, remembering, of course, that each of these lines is times and each of these horizontal lines is divided by. The first thing that you're going to do is put whatever is in the top of the first section into the bottom of the second section, so it's grams of N2O3. And we are converting to moles. So we know that 1 mole of any substance is equal to the molar mass. And the molar mass is in grams. So that means if we have grams down here, we can put moles of N2O3 up here. And we know 1 mole is equal to the molar mass in grams. So we have reached the unit that we are trying to convert to, which is moles. We can cancel grams. And then now just what we have to do is find the molar mass of N2O3. So if we look on our periodic table, well, first of all, we have nitrogen and we have oxygen. And we have 2 nitrogens and we have 3 oxygens. And so looking on the periodic table, nitrogen is right here and it has an atomic mass of 14. Now we're going to go always 1 decimal point out, so that will just be 14.0. Oxygen right next door has 15.999. But if we want to go only to 1 decimal place, we're going to have to round that up. So it's going to be 16.0. So when we take those numbers, what did I just do? I don't know. When we take those numbers, we will take 14 right here, and that will equal 28. And then this is 16, so 16 and 16 is 32, 42, 48. Add that together, and of course you can use your calculator, and you get 76. Now, that number is the molar mass for N2O3, and that's what will go right here. So, again, we are saying that we have 75 grams of N2O3. If we know that 76 grams is equal to 1 mole, how many moles do we have when we have 75 grams? So what you're going to do is you're going to take 75 times 1 and divide it by 76. And that's how you get your answer. So it looks like it's going to be about 1. So when I do the math, and I do actually do the calculation, 75 divided by 76 equals 0.9864. Now, we were given in our question 3 significant figures, 75.0. This 0 is significant because it's a trailing 0 and there is a decimal. So our answer will end up to be 0.987 because this is one significant figure, this is the second, this is the third, and this 8 will make the 6 round up to a 7. And our units are moles of N2O3. Now, I'm going to stop there. At this point, we have done representative particles and we have done mass. And the last one we will do is volume, but I'm not going to do that right now. So one thing that some of my students found to be helpful last year is they actually did some color coding. So if you wanted to get a marker or a colored pencil, you could shade a color to remind you of the term. So for example, if I were to want to remember particles, I would say, okay, particles, pink, and I would shade this area in colored pencil pink. And then if I wanted to remember mass, I would think of maize, which is yellow, and I would shade this area here yellow for maize, like maize in blue. You can start to color code this if you wanted to, or you could just put a block around it or something. But just so you know that you have a relationship between the color and the thing that you're doing. Now, the last thing I want to say is that I do want you to try some of the problems on this sheet that you picked up, the yellow paper. And I want you to try the following. I want you to try number 1. I want you to try number 2. I want you to try, number 2. I want you to try number 5. And I want you to try number 6. So just 4 of them only. Please show your work just like I did. Use my examples that I just showed you. And I also have attached videos of how to do these problems. I have a playlist. So please use your resources.